Hi, welcome to Chem 300 Virtual Lab. So in lab this week, we will be doing the graphical and mathematical relationship between mass and volume. The purpose of this lab is for students to learn how to measure the density of a substance. And there are two different ways how to determine the density of a substance. Using a set of data that we collected, you can perform first the graphical method to determine the density of a substance, and second, the calculate average method to also calculate the density as well. So those are the two methods that we can use to determine the density of a substance. Again, it is the graphical method, and second, the mathematical method. And we'll discuss these two methods in a little bit. And here is the outline of this experiment. So first, using a sample set of data that is assigned to each of the students, which in each of this sample set, it includes 3 different pieces of the same substance or a metal. And your goal is to determine the mass of each of the pieces based on the data that they are provided. And we also provide the corresponding volume measurement of the object as well. And when we know the mass and the volume of the substance, you will then be able to determine the density of the substance. And again, we'll be using 2 methods to determine the density. One method is the average method, which gives us one measure of density value. And the other method will then be the graphing method, and that gives us another density as well. So you will then calculate the percent error of this experimental value right here, and then completing the rest of the lab report. And this lab report right here is due at the end of this week. And here are the sample assignment right here based on your last name. There are 6 different samples all the way from A and F. And students, depending on your last name, are assigned this following sample. If your last name starts from A to E, you'll be assigned sample A. So make sure you include sample A in your report. So that way we know that you're working with sample A. And if your last name is start with F to J, then you would have the sample B and so on. So please refer to this list and make sure you are using the correct sample. And here are the sample, the data for the different sample. In this case, this is the sample A, which have this purple color in here. So these are basically the masses of these 3 pieces of metal, and they're the same material or same metal. So this is the first piece, and now in this case right here, this analytical balance right here and the weighting both will tear before we put this metal or this object in. So in this case right here, this mass right here directly correlate to the mass of this object number 1. And here the second object, which is a different object. And now this is the mass that it corresponds to. And similarly, this would then be the mass of the third object. Now from what we can see, object 3 is much bigger than object A, right? And in this case right here, its mass is also much bigger than object A as well. So please record these masses right here if you have sample A. And now, these are the volume of the different object that we have here. So in this case right here, how this experiment is done is as follows. When you refer to the instruction from the lab manual, first you will then take this glass cylinder and then you will then fill this up to the volume of 20 milliliter. And in this case right here, if we were to be reading the volume of this, it would be 20.0 milliliter. So initially, that was the initial volume. This is basically the volume after this object right here have been added to this volume of water. And in this case, we can see that initially it was 20.0 and now it changed much higher than 20 right now. So in this case, you are asked to basically figure out what would be the reading of this volume. And again, make sure you use rule of significant figures and round your answer to 1 decimal place of a milliliter. Okay, and this will then be the final volume. And similarly, this will be the final volume of the second object. And again, to figure out what will be the volume of this object, you will have to take this reading right here. And in this case, this is the mark for it. Subtract 20, because initially it will fill up to 20. And that will then give you the volume of this object number 2. And this is the volume reading of the object number 3. And if you were to have sample B, then these are the data for sample B, the mass of different objects in sample B. And these are the volume of object B. And again, please remember that the instruction basically tells us to first fill up the volume to 20.0 milliliter and then add in the object. And now we can see in here, this volume right here is the volume of both the object and the water. By subtracting this final volume right here with the initial volume of only the water, then that will then give us the volume of the object. And please follow this following to figure out the volume of object 1, 2, and 3. And these are the same object that we have seen previously in the on this page. And these are the sample, the data for sample C. And here's C again. And this is sample D. So depending on the sample assigned to you, please refer to the correct data and get the data for them. And to the end, you will be able to complete this table right here. So there are 3 objects or 3 metal 1, metal 2, and metal 3. And you will then be reporting the mass of these 3 different objects or 3 different metal in this following row. And now this is the final volume right here. So initially, the initial volume in this case right here, we are just given this as an example. So let's say initially the volume is 20 milliliter. And after we add in this object 1, now the volume becomes 23.8. So to figure out what will be the volume of the object, you will then take this V final minus V initial. And that will then give us this volume. And similarly, you can do the following to figure out what will be the mass of object 2 and object 3. And to then calculate the density of the metal, we can see already the density equal to mass divided by volume. So if we were to take this mass, 10.0115 divided by the volume of 3.8 milliliter, then we'll be getting the density of 2.63 gram per milliliter. So this will be the density of this object 1. And now for this object 2 of this same substance, then we would expect the density to be exactly similar, right? But in this case right here, experimentally speaking, we cannot expect them to be exactly the same thing. So in this case, based on this mass and this volume, the density of this second object right here is then 2.743 gram per milliliter. And same thing for this. Now, it's important that you keep this value right here unrounded. Underline how it should be rounded, but do not round it because we do not know how to round this value yet. And this is very much similar to what we have done from the previous week. Anytime we have experimental value, to figure out how to round the average value, we have to first calculate the standard deviation. So in this case right here, these are the density of the 3 metal in 3 different trials. Each of this object right here will give us one trial. In this case, we will then first calculate what is the unrounded average, which equal to this first data point plus this data point plus this data point right here, add them together, divided by 3. And that will then give us this density value. So on average, it will be 2.70367 gram per milliliter. And it's important that you write out this unrounded value right here. To now figure out how to round this value, you will have to first calculate the standard deviation. So when we calculate the standard deviation of these 3 data points, it becomes 0.063846. And after that, we'll then be rounding this to one significant figures, just like what we have learned from the previous lab. In this case, it equal to 0.06. And now this value have 2 decimal places on it. So this now tells us to now go back and round our average to 2 decimal places. So therefore, this would then become 2.70 gram per milliliter. So this would then be the density using the average method. And again, calculate the average, and initially do not round it, then find the standard deviation. And it is the standard deviation that will tell us how to round our average value. So make sure you round your answer correctly, because I will be looking for this as I grade your lab report. And now, we can also calculate the density by using the graphing method. So the three data points that we have previously, this mass and this volume, this mass and this volume, and this mass and this volume, this becomes 3 data points. And we can put these 3 data points together in a graph. And the slope of this best fitted line right here will then equal to the density of the substance. Okay, and as you plot your graph, make sure that you are putting the mass on this x-axis and this volume right here on this y-axis. And in this case right here, make sure you label your axis as well. Again, make sure you put mass right here and volume right here. And so again, the density is basically change in y over change in x. And this is something that hopefully you still remember from your math classes. By taking out, once we have draw this best fitted line right here, we can now pick up 2 data points from the line. And using that 2 data point right there, we can then do a change in y over change in x and be able to find the slope of the line. And the slope of this best fitted line right here will then equal to the density of the substance. And this will be the density using the graphing method. Now, it's important that you scale your graph effectively, so that way you are able to utilize the entire graphing paper to do this density estimation right here. And in order for you to actually utilize almost the entire piece of your graphing paper, you have to work out your increment correctly. So that way you are using the entire paper. And the method to do that is as follows. First, on this axis right here, this is where we're going to plot all of the masses. And I'll take a look at your masses right here. In this case, we see the smallest mass is 10 gram and the highest mass is about 70 gram. So basically, we want to plot or label this axis in such a way that will cover all of these masses. And now that gives us a clue that if we were to set the minimum to be 0 and the maximum equal to, let's say, 75, then that will then cover all of this data point. So all of this data point right here would then be on our graph. Okay. And so basically in this case right here, we can set the origin to be 0 and the highest point to be 75, and that will cover all of the masses that we need to see. And that would then allow us to calculate what is known as the range. So this range right here is basically the highest point minus the smaller point. So in this case, 70 minus 0 equal to 75. So 75 minus 0 equal to 75. And the next step is for you to calculate how many increments that we have going from here. So in this case right here, we can see if we were to count all of this equal to 34 increment. So we have to basically go increment. We have to go from 0 to 70 up here. And so basically how much each of this have to increase by. So when we start at the origin to be 0 and get by a time that we get up here, it will then equal to 70 something. So that tells us right here. So this is the way how we will figure out what the increments should be. So that way it will increase correctly. So what we will then do as follows. Take the range that we calculated from here and divide that by the number of increment. In this case, 75 divided by 34 equal to 2.2. And then this 2.2 value right here doesn't seem to be like a good value, right? Because increasing by 2.2 is quite difficult to keep track. We want them to be whole number or half number or a quarter of a number. So therefore we can either round this to 2.25 or 2.0. And if each of this is increased by 2.0 or 2.25, then by the time we get to this highest point, this will cover all of our masses. And make sure you do the same thing to figure out what should be the increment for the volume. And after you have determined the density of using this graphing method right here, then you should now have two density value, one for the graphing method and one for the average method. So in this case right here, this value, when we take this, after we have put in this best fitted line right here, pick 2 points that fit into this line right here, and please refer to the instruction from the lab manual to learn more about how to do this best fitted line right here. But it's a line that goes through the average of your data point, and in one single straight line, and it should try to go through your data point as much as you can. And after we have drilled this best fitted line already, pick 2 points where on this line, and we can use that 2 point right there to find the slope of the line. And the last calculation that we now need to do is to calculate the percent error. So the percent error is basically the quantitative way how we can describe the accuracy of our data, because every substance has its own density, and now we measure its density. So how well do our value agree with the actual value? That's what the percent error is, and that the smaller the percent error, then the more accurate our data would be, versus the larger the percent error, then the less accuracy that we will have in our data. Okay, so now you should have two density value for the same sample, one using the average method and the other will obtain using the graphing method. They should be quite similar together, but not entirely. And now you then calculate the percent error for each of your experimental density value. So I'll be expecting to see 2% error. One is for the graphing method, and the other one is for the average method. And this is how you calculate the percent error. The value that you obtain using the average method and the slope method is called the experimental value. You will then subtract that by the accepted value, divide that by the accepted value, then multiply by 100. So this accepted value right here is also called the actual density. So now what is the actual density of the substance? And you then compare that with your experimental value. Dependent on the sample they assigned to you, these are the accepted or actual density over here. So please refer to this table so you can figure out what will be the accepted or the actual density of your sample. Okay, and here is sample calculation right here. Make sure you use significant figure in this calculation. So for an example, let's say here that the experimental value is 26.98 and the accepted value is 27.03. To figure out what this percent error would be, you will then take 26.98, subtract 27.03, divided by 27.03, multiplied by 100. And then based on the math that we do here, make sure you round, underline how it should be rounded, and finally do the calculation. And round this based on significant figures. So again, there should be 2% error for the two density value that you have. And taking that data, you will then put your sample on this. So the density, again, so please put in your density, and this should be the rounded value right here, and the percent error. And under the sample name, this is where you will then put sample A to F, depending on which sample that assigned to you, and using the actual density value that we have provided you with. And please show the calculation of the percent error, just like showing the calculation for the average density that you have above here. So make sure you show work, and for the slope method, then make sure you show work by writing directly on the graph. And when you finish, please answer the rest of the other questions and submit all of your data and the calculation, and that will be your lab report.